Uh, Hi, hello everyone. Welcome to my YouTube channel. I'll be solving LeetCode 75 questions using Go programming. So let's look at today's question. Move zeros. Given an integer array nums, move all zeros to the end of it while maintaining the relative order of non-zero elements. Note that you must do this in place without making a copy of the array. Let's go to the drawing board and understand how this is done. Yeah, basically, here in this example, what would be the answer according to the question? Answer should be uh, all non-zero element should come to the front, that is 1, 3, 12, and all zeros should be at the end, 0, 0. So let's take one more example. If you have 0, 0, 1, 0, if you have this as the example, it should be one non-zero element 1 should be at the beginning, followed by all zeros. So this is example 2, this was example 1. I hope you understood the question. Pretty simple. Non-zero element should be at the beginning, 0 should be at the end, and the relative order of non-zero element should be maintained. That's the question. Now let's see how we can solve this. 0, 1, 0, 3, 12. This was the question. So brute force, let's say you were allowed to use extra space, because if that is the case, that's the most brute force way of doing it. If you were allowed extra space, you would basically go from I is equal to 0 to n, append num of I not equal to 0 to res, and you would also count zeros. Okay, so at the end of this loop, your res would have been something like 1, 3, 12, but you would have counted zeros also. So two zeros are there in the array, so just append two zeros at the end and return res. That's what you would have done. It would have been O of n, but it's not in place. But the question specifically asks us to do it in place. So that's why this sort of an approach won't work here. What we need is like a two-pointer approach to solve this problem. One pointer to record the position at which will be writing, and one pointer to sort of loop through the array. That's exactly what we are going to do. We'll be have two pointers. One is POS position and other is I. This is the location of non-zero element to write. So non-zero elements will be returned at this position, and I is just a looping variable. It goes through the entire array. Okay, now let's just do a dry run so that you understand it much better. So initially, what is the case? Both position I will be at the beginning. Okay, and you need to move I so that it's non-zero. So which is the first non-zero element? 1. So I will be here. Now copy whatever is at nums of I into position. So copy 1 to position, and whatever nums of I you make it 0. Okay, so 1 came to position and I you made it 0, and then position you increment, and I will be taken to next non-zero element, which is 3. Okay, which is 3. Now again copy 3 to position. So 3 will be here, 3 will be here, and then make nums of I 0. Okay, now again as soon as you write into the position, increment position, and I always goes to a position which is not equal to 0. So next is 12. Same thing, copy 12 to position, and then make I 0. So this is your resultant array 1, 3, 12, 0, 0. All the non-zero elements are at the front, 0 elements are at the end. And there is one more edge case here. You need to avoid conditions where I becomes equal to position. Why is that? Take this example. So let's say you had an array which had only this element, only one element, which is 1. What should be the result? Result should be also 1, because there is no 0 to move it at the end or anything. There is just 1, it should be 1. So in this case, I and position both are at the beginning, right? So what you would do, you would copy whatever is at nums of I into position. So 1 will be copied into 1, it's the same location. But you would make nums of I 0. You made this 0. This is incorrect. You are not supposed to make non-zero element 0. That's not the objective of the question. You are only supposed to move the zeros to the end. So this violated the constraint of the question. So that's why we need to avoid conditions where I is equal to POS. Okay, I hope you understood that. Now let's go back to the editor and let's write the code. Code is again pretty simple. Initialize position, I will be 0, I less than len of nums, I plus plus, and then if nums of I not equal to 0, as I mentioned, I will only point to location which is not equal to 0, and I is not equal to position, so I shouldn't be equal to position also. Now what we would do, you will write nums of I into POS, and next step is to make nums of I 0, and then increment position. You don't have to return anything because the question doesn't expect you to return anything. Let's run the code. Yeah, it's accepted. And one more thing, I think some of you might be wondering, why are we incrementing the position here and not inside the loop? So basically, whenever nums of I is not equal to 0, that means we need to sort of copy nums of I into nums of POS. We are avoiding I not equal to POS because essentially you will be recopying the same element into POS. But still, even if you're recopying the same position into POS, at the next iteration, you need to be at the next position to sort of copy the next element. So regardless whether I is equal to position or I is equal to position, you need to increment position as and when you see num of I is not equal to 0. I hope you understood the explanation why POS should be outside. If not, try to dry run yourself with couple of examples, you will understand why. Now let's analyze the time and space. Time complexity is O of n because there is just one loop, and space is O of 1 because you're doing it in place, so you're not using any extra space. Thank you so much for watching my YouTube video.